You're thinking about depositing $4,000 at the end of each of the next 3 years in a bank account, paying 8% interest. You currently have $7,000 in the account. How much will you have in 4 years? So here you're trying to determine the future value of multiple cash flows, and the future value of multiple cash flows is simply the sum of the future value of each cash flow. And now we need to draw the timeline to put down where each cash flow is going to be and try to determine the future value. So we're trying to determine how much you will have in the account in 3 years, and how much will you have in the account in 4 years. Let's first determine how much you will have in the account in 3 years. So this is what the timeline looks like. We have time 0, and then we have year 1, year 2, year 3, year 4, etc. The problem is telling us that you currently have $7,000 in the account. So that $7,000 is going to be the amount at time 0, because you currently have that amount. And then the problem is also telling us that you're thinking about depositing $4,000 at the end of each of the next 3 years. So here you're going to deposit 4,000, and then 4,000. And the problem is asking how much will you have in 3 years. So here we're looking at the future value at the end of year 3. Okay, so the future value of multiple cash flows is simply the sum of the future value of each cash flow, and so this is what we are going to be doing here, determining the future value of each cash flow. This $4,000 was deposited at the end of year 3. We're trying to determine the future value at the end of year 3. That $4,000 had no time to grow, and so the future value for that amount is going to simply be 4,000. So here, future value equals to 4,000 because it didn't have any time to grow. For the $4,000 that was deposited during the second year, this one has 1 year to grow. So we apply the formula. Okay, so 4,000 times 1 plus R. The R in this case is 8%, so it's 8%. We include it as a decimal, so it would be 0.08, and this 4,000 has 1 year to grow, so we raise it to the power 1. This will give us a future value of 4,320. We're going to do the same thing for the 4,000 deposited at year 1, so 4,000 times 1 plus R, which is 0.08 to the power t. Here, this 4,000 has 1, 2, so 2 years to grow, so it would be to the power 2. And so the future value here is 4,665.2. Next, we look at the 7,000 that was deposited at time 0. This one has 1, 2, 3 years to grow. So it's going to be to the power 3. So 7,000 times 1 plus 0.08 to the power 3. This gives us a future value of 8,817.98. Now we have all of our future values. All we need to do now is sum them up. So plus, plus, plus. The total future value at the end of year 3 is 21,803.58. The next question is, what is the future value at the end of year 4? So how much will you have in the account in 4 years? Okay, you can do the same process, so that this 4,000 will have 1 year to grow, this 4,000 will have 2 years to grow, this 4,000 will have 3 years to grow, and this 7,000 will have 4 years to grow. Or you could just take the future value at the end of year 3 and grow it for 1 year. And this is what I will be doing here. Future value at end of year 4 is simply the amount that we have at the end of year 3. So it's the 21,803.58 times 1 plus r, which is 0.08, to the power of 1, because it has only 1 year to grow. Well, this will give us a future value of 23,547.87. So at the end of year 4, you should expect a value, your account to have 23,547.87 if the investment gives you 8% and you have the cash flows that you and we have these cash flows that we initially included in this account.